as soon as it starts recording.
Yeah, okay, so yeah, we started probability yesterday, and we first looked, before we talked about what probability is, we started talking about different ways that we can express probability, right? So we can express it in really three ways. You'll see it. Like, we can also express it in words, like 1 out of 3. But really, in our case, we'll be dealing with how we express it in numbers, right? So we can express it as a fraction, a decimal, or a percentage, right? And then we talked about ways to convert between these ways, or these forms are 4 ways to express probabilities, right? So we talked about if we're going from decimal to percent, right? We times by 100 and so on. And then just down here we talked about kind of those steps to follow when converting decimals to fractions. Right, so we talked about converting between those forms as well. But then so there was this page here for simplifying fractions, but Mr. Dirksen actually told me that they don't, the province, I guess on your final exam, you're not required to reduce or simplify fractions, so I just skipped this for now. And then before we started looking at probability, we talked about a standard deck of cards. So many of you may be familiar with the standard deck of cards already, but the reason this is in here is because a lot of questions about probability, right? There's a lot of good questions to ask about a standard deck of cards. So just making sure that you know, kind of, if you're not familiar, you have this page, and you can kind of maybe make a table like this on your study sheet so that you know kind of what's being asked, right? So, right, if I ask you how many, like, what is the probability of drawing a heart out of a deck of cards, right? You know that there's 13 hearts, and in a standard deck of cards there's 52, so it would be 13 over 52. So just knowing that is useful for these questions. And then we started actually talking about what probability is. So, right, we know that probability is the likelihood, right? It's the likelihood of an event happening. What that event could be anything, right? Drawing a certain deck, or drawing a certain type of card from a deck, the probability of winning the lottery, the probability of winning at any game. So there's 3 ways to present probability, but the way that we often figure it out first is using I guess kind of the definition is it's stated as a fraction, right? So we have the probability of event is the number of favorable outcomes, so say, or like desired outcomes over the total number of possible outcomes. So I did an example up here, right? We're rolling a dice and we want to know the probability of rolling a 6, right? How many ways is there to roll a 6 on a 6-sided dice? 1, right? So you'd have 1 in the top, and then how many possible outcomes of rolling a dice is there? There's 6, right? 6 sides. So then the probability of just rolling a 6 would be 1 over 6. The probability of rolling any number, if it's a fair dice, right, would be 1 over 6 for every number. But that was kind of what probability is. And then an important thing about, or important characteristic about probability is that it's always between 0 and 1, if we're thinking about decimal or fraction, or it's always between 0% or 100%, right? And this, again, can act as a quick mental check, right? If you're doing a question and you're finding a probability and you get an answer that is greater than 1 when you're talking about fractions or decimals, or it's greater than 100%, or it's negative, then you know that you most likely made a mistake somewhere, and you should go back and check. So your answer should always be between 0 and 1, or 0 to 100%. And this outcome, or this characteristic, gives us this this equation here. So if we look at the probability of an event happening, and we add the probability of that event not happening, well, that adds up to 100%, right? You can either roll a 6 or you don't roll a 6, right? And the probabilities of both of those, so we call these complements of each other, right? Because they complement each other, right? The probability of an event happening and the probability of that event not happening equals 100%. So we can use that to get these equations here just by rearranging this one up here. And so for notation's sake, we just do PE, right? E is just any event, so it won't always be E, but just so we don't have to write probability every time. And then we use this line above to represent like the not. So say probability of rolling a 6, this would be the probability of not rolling a 6, and we just use the complement, or this line above, to represent that of an event not happening. But you can also use words if you forget the notation or this doesn't make sense. But we can rearrange this equation to get these two. And we saw that this can help us in certain questions, make our life a little easier. And then we went over some examples just of finding some probabilities and this right here of making predictions, right? So we can make predictions. If we know the probability of rolling a 6 is 1 over 6, then we can find out, we can apply that probability to make a prediction of what would happen on a greater scale. So, right, the probability one time of rolling a 6 would be 1 out of 6. But then we could say, well, how many times could we roll? How many times would we expect to roll a 6 if we rolled the dice 300 times, right? And this is how we'd make that prediction. We'd take that probability of just rolling a 6 one time, and we'd multiply by that sample size we got. And then we did some examples of that there. And then I assigned for questions for homework. Questions 6 to 8, which are, were there any questions on that, on those questions? So again, it was just finding probabilities, and some of them were about making predictions. If there are no questions, I will do another, I'll do another example, and then we will do some board work on the deck of cards example, because I just want to make sure, see how we are with, right, because there's a lot of questions that you can ask with the deck of cards, so I want to make sure everyone's good with kind of, if you're not familiar with a standard deck of cards. So maybe I will start with this example here. So, right, we have that Georgina bought a bag of bulk candies. She counted them and found that there were 15 red, 10 green, 12 purple, and 13 orange. And we want to calculate, for part A, the probability of a randomly chosen candy from the bag being red. Right, so this is, so the reason we say randomly chosen, which again is actually it's a small word, but it's actually very important in probability, is that, right, randomly chosen just means that there's no bias. There's an equal chance of picking any of the, in this case, candies. There's an equal chance. So randomly chosen candy from the bag being red, express the probability as the three ways we talked about. So we have the probability of picking a red candy, right, would be number, right, so the number of possible outcomes, so number of red candies we can choose over the total, in this case it would be the total, it would be the total number of candies. Right, so this would just be how many, so we're not given the total, but we're given all the different colors. So we can find our total by just adding them up. So we have 15 red in total, and total number of candies, let's find that quickly. So I'm just going to do it up here. So, or maybe I'll just do it to the side here. So we have total equals, right, 15 plus 10 plus 12 plus 13. Right, so I'm just adding up all of the different colored candies, and that gives us 25, 37, 50 candies in total. Right, so that would be our answer there. So right, most likely whenever we're finding probabilities, you'll always find it in fraction form first, because just based on the definition. And then so we want to state it in a fraction, in a decimal and a percentage as well. So, right, all we do is just do 15 divided by 50, and that will give us the decimal, right, which is 0.3. So 0.3 as a decimal. And to find the percentage, right, we just multiply, so to convert from a decimal to a percent, we just multiply by 100. So that would be 30%. Right, and in words, it also says in words, so that would be 15, let's say 15 out of 50. Part B says, what is the probability of randomly chosen candy being green or purple? So being green or purple, right? So I'm just going to, right, green, probability of green or purple being chosen. Right? So again, we have, what would be our numerator? It would be the number of possible candies that we pick that is either green or red. Right? So what we do is we just add up, oh, not red, sorry, green or purple. Right? So it would be, there's 10 green candies, 10 possible green candies that we can get, and there's 12 purple. Right? So this accounts for green, and this is purple. And then we divide that by our total, which is 50, right? And that gives us 22 over 50, right? And if we want to, again, just convert to a decimal, it's also 0.44. And then to convert to a fraction, or sorry, a percentage, we just multiply that by 100. So it'd be 44%. Or words, it would be 22 out of 50. And then for C, if the distribution of colors in a bag of 1,000 candies is the same, how many would Georgina expect to be red? So you may see this if the distribution of colors in a bag of 1,000 candies is the same. So all this means is that there's an equivalent, it's proportional. So there's an equivalent amount of red. There's obviously not 15 red, there's more, but the ratio between the candies is the same. They're spread out the same. There's an equal amount of the ratio between the reds, the greens, the purples, and the oranges are the same. So what that means is that we can just use this information and apply that to if there were 1,000 candies. And we want to know, so we're looking for how many would we expect to be red. So this is a prediction question, right? Because we are given, in our normal question, we had 50. This time we want to forecast or predict how many would be red if we had 1,000. So our prediction equals the probability of there being a red times the new total, right? So I don't know what it says. What does it say in the notes? It calls it. Yeah, so the greater times the, we'll just say sample size. In this case, it's greater. Right, so our sample size was originally 50. Now we want to make a prediction on if we had 1,000. So we can use, since the distribution is the same, we can use our answer in part A, right, which we found was 15 out of 50. So for this part here, can we use right? So there's 3 ways to represent probabilities. Which ways can we use in this formula here? Yeah, we can use fraction. Can we use another way? Or another form? Yeah, we can use a decimal as well. So the only one we can't use is 30%. You can't plug in 30% here because it'll give you the wrong answer. It won't work. But we can use fraction or a decimal. So I'm just going to use a decimal and then times our sample size, which is 1,000. And that gives us, well, 30% of 1,000 is 300, right? 300. So 300 expected to be red out of 1,000. Any questions on that one? All right, so For this one here, consider the letters in the word probability if the letters making up this word were placed in a bag, so very similar to the previous question. State the probability of drawing an eye. So we're not given numbers here. It's a little bit different, the information we're given. So we want to state the probability of, I'll just say an eye here. Right, so what would be the number in the numerator? What about the denominator? Right, so how many, right, we're not given numbers, but if we were to place all of the letters in a, let's say in a bag, and to draw one, right, so the number in the numerator would be the number of eyes in probability, just as if, right, I was, let's say, equivalent to red, right? There were 15 red. This time we're drawing eyes, so there are two, right, two of them, and there are 1, 2, 3, 4, 5, 6, 7, 8, 11 letters to choose from. So that would be our probability. I'll just leave it at that. Right, so there's different info, right? So you can just be given, you can also be given the total. Like this one, we had to figure out the total because we were given the numbers. This one, we had to figure out the total as well as we had to just count how many eyes there were. We weren't given the numbers instead. Part B is state the probability of drawing a vowel. So probability of vowel, right? Numerator would be number of vowels over the total number of letters. Right, so there are 1, 2, 3, 4 vowels, and there are, right, still 11 letters, so that would be our probability there. So we are going to get into groups. I'm going to pause this for a second. So yeah, so right, there could be a question, a probability question asking about a deck of cards. So just make sure you get used to answering probability questions with decks of cards, and remembering, you know, how many suits are there, how many are in each suit, how many face cards are there.
For future references, like for test and quiz, do we have to memorize cards and like how would we complement, or do we have it as a reference for quiz and tests?
So for your study sheets, I would recommend, like, you can summarize it however you'd like. So it kind of breaks down, kind of like they're kind of in groups. So again, you can kind of break this down to whatever you'd like. I broke it down to like a tree, kind of like we think of factor trees, I guess. But so you know that there's 52 total, and out of those 52, you can break those up into smaller groups of 26, so black or red. So I just use notation B or R. And then you can break each of those groups of black or red up into suits, or sorry, not suits. Yeah, suits. Sorry, right. So you have hearts and diamonds, 13 and 13, and spades and clubs are the black cards, so 13 and 13 there. So you can kind of make like something like a kind of like a summary like this on your study sheet that you can refer to. Makes sense.
Sorry, I was going to interrupt because I happened to have this one last semester. I made one of those.
Okay, yeah.
It's
So
basically the same.
yeah, so you can organize it like however you'd like, whatever makes sense to you. Like this is more of like a table.
Yeah. Find creative ways to add it to your study sheet because I would expect you to know your deck of cards. Yeah.
So yeah, I could yeah, because there's a lot of questions that I can or that they can ask about a deck of cards. But like I said, there's a lot of questions, all very similar, dealing with different situations. So but we're going to move on. I'll post the solutions to all the way up to page 15. Again, they're all similar, and we're still going to be dealing with some similar questions. But we're going to move on to converting or looking at what odds. We say, what are the odds of something? Right? What are we actually talking about? It's pretty much another way of stating the probability of something. It's just a little bit different than what we've looked at before, but very similar. So this is on page 16. So you see that odds are similar to probability, but does not show the total. So the main difference here does not show the total number of outcomes, right? But it is very easy to see what the total number of outcomes. You can still get the total number of outcomes if you're given odds, and we'll see that when we convert between probability to odds. But that's the main difference. So what are odds? It compares the desired events to the number of undesired events. So pretty much it's a way of saying how many desired events compared to undesired events there are. So for example, if I'm looking at odds, so let's say I ask for the odds of drawing a face card out of a deck of cards, right? So the probability, we know there's 12 face cards, there's 52 total, so the probability would be 12 over 52. But if we wanted to state the odds, right, we'd state it like desired events, and then we put a colon, and then just undesired events. So it would be 12, because there's 12 face cards, and then the number of undesired events, right? So we know there is 39, right? And I got this just by going, right? So if there's numbers that, right, you can't subtract in your head, right? This is just, or you don't know where I got this from, it's just 52 minus 12. So it's total minus your desired here. So we're stating desired events, and then what's left over, the undesired events. Right, so we can think of it as different ways. Desired events, what's happening, what's not happening, what's in favor, what's against. So these words may show up in there's different ways of asking or stating it. But really, when you hear something like the odds of something is 12 to 9, that's what that means, right? So there's 12 possible ways of that happening, and 39 ways of that not happening. Right? So we can convert, again, they're similar to probabilities, so we can convert between the two, right? So if we're given odds and we want to convert to the probability of, so let's say we have favor against, so let's say the odds of there being snow versus no snow, right? So if I give you the odds of there being snow, and then I say what's the probability of there being snow, what it is, right, you have what's in favor for, so the number of, say the number of days there are snow over the total number of ways, right? And then for the probability of there being no snow, it's just against, right? We just have the opposite of what's happening in the numerator. Right, so this is just converting odds to probability. And then we'll look at how to convert between the other way around. Right, so let's do some examples here to see how to do this. So the odds of the Jets winning the next game are 8-2. Probably be less if you keep up with the Jets. They won their last game, but that was after a 6-game losing streak. But anyway, if the odds are 8-2, explain what the numbers represent. So what would 8 represent? So 8, what we could say, how would I say this? Explain what the numbers represent. Eight to 2. So let's say there are 10, right? There are 10 ways for over the next 10 games, but we're thinking of the odds of the Jets winning the next game are 8-2. So we can say that if we repeated the next game, they'd win 8 out of the total. There's 10 games, right? So there are, let's say, 8 ways the Jets will win the game. And for the 2, right, there are 2 ways for them to lose the game. Right, so the 8, again, this is just asking the number in front is what's desired. In this case, we want the Jets to win the game. So the 8 corresponds to the Jets winning the game, and the 2 corresponds to the Jets losing the game. So state the odds against the Jets winning the next game. So what would be the odds against the Jets winning the next game? Yeah, so it would be, so it's asking for odds, right? So when it always asks for odds, we want to think of stating it like this with a colon. So that would be the probability of the Jets losing the next game. But the odds of the odds against the Jets winning the next game is 2-8. So we just flip. We have against on this side now. And we have favor on this side. And on this side we had, right, it was originally in favor for and against. So we just switch it. Does that make sense? We just switched them. So then state the probability of the Jets winning the next game. So now we want to state the probability. We're given the odds. So now I want the probability of winning. Right, so how many ways can the Jets win the game? 8. And the total, or this is in favor for, and then we just add the 2, favor and against. Right, and that would give us 8 over 10. Right, and again, no, I won't even reduce it. I'll just leave it like that. So that would be the probability of the Jets winning the game. And if we wanted to convert, right, we just plug this into our calculator. It'd be 0.8 or 80%. And then the probability of the Jets losing the game, right, the same way. It would be probability of losing would be 2 over 8 plus 2. So just be 2 over 10. And say, for example, this is so there's a lot of ways that you can kind of mentally check if you're on the right track in some of these questions. So for this one, right, say this was on an exam or a test, and you got 8 over 10 and these two numbers, right, so these are complements of each other. The Jets can either win the game or they can lose the game. So, right, because you can also state it, again, if you don't, if you get confused by this notation, that's okay, right? But the probability of losing is just the probability of, right? And this just means this line above this means not. So it's the probability of not winning, right? And we know that probability of winning plus the probability of not winning, or I'll just put, since it's in your notes like this, of winning, I'll just put the line for not, this should equal 1, right? So that tells you that these should both add up to 1. And just mentally check, they do. So again, if this was a question on an exam, you can do a quick check. If these don't add up to 1, then you could, you went wrong somewhere. So this would be 0.2 or 20%. So again, this characteristic, right, is very useful when we're dealing with, right, events of something happening or something not happening. You can use it to check our answers. Another example here, use the spinner below to answer the following. The odds of the spinner landing on green. Right, so again, it's asking for odds. Right, so when you see odds, you should right away think, right, so we have favor and against. Our answer should look like 2 numbers on either side of that colon. So the odds of the spinner landing on green. So this is say landing on green versus not landing on green. Right, so now this is just the number of ways of landing on green. So we just count that there is, right, there's only one green spot. So it would be 1. Should have lined up the colon here, but. And then there are 1, 2, 3, 4, 5, 6, 7. There are 2 green, thank you. So it would be 2, yeah, 2, 6. Thank you. It's always a good idea too, even like in a probability question, if you're not given the total, and if you can quickly do it, just to find the total, because then you know that, like, right, these two should add up to the total because it's for and against. So we know that there's 8 total outcomes. Sorry. Yeah, it's recording right now. Yeah, so I'll post it like the same way that Mr. Dirksen does. Yeah.
Thumbs up, subscribe. The bell.
So then the probability of the spinner landing on green. So what would be the probability? Yeah, I heard someone say 2/8. Right, so the first number is always in favor for, and then we just add those up. Right, I got this by adding 6 plus, just adding the for and against, or favor and against. So I'll give you a couple minutes to work through these other ones. And then there's about 15 minutes left of class. And then we'll see how long that takes. And then I'll go through. I'll circulate around if you have any questions. And then I'll quickly go through it. And then we'll see what the time is. If we look at the odds of the spinner landing on red, right? We have in favor of red, and think of this as not red, right? So we have 3 ways, 3 spots we can land on red. And then since we know the total, right? We know that oh yeah, that's what it reminded me of actually. Yeah. So, and we know that, right? So we should know that all these, right, A, C, E, and G should all, if we add the favor and against, it should always add up to our total, which is 8. So that's why it's always a good idea. Like, it's not required to find the total, but well, I guess it is here. But just again, a good check. The probability of the spinner landing on red, right? So the probability of red would be number of ways it can land on red over our total, which is 8. So the odds against the spinner landing on yellow. So now we just switch it. So now we have not yellow versus yellow. Right, so the number of ways of not landing on yellow. So there's 1 yellow space, which means there's 7 ways to not land on yellow. So the odds are 7-1. And then it's the probability. Yeah. So this would be, so again, I'm just going to use this notation. So this just means not yellow or against yellow would be 7/8. And then the odds in favor of the spinner landing on yellow. So yeah, so we can just use, we don't even have to look at the spinner if we didn't want, right? So this is just yellow. It's just switching part E around and not yellow, right? So it'd be 1/7. And then the probability of the spinner landing on yellow, again, would just be, in this case, it's easy to count, right? It's just, or from the odds, we get 1/8. And then we should see that these should add up, which they do because they're complements of each other. So that's, again, converting odds to probability. For, let's see. So I think I'll give you the, so if you want, there are the next 3 pages, so 18, I'll just write it up here actually. Page 18 to 20, there's more examples of, again, converting, stating the odds, again, just different scenarios of stating the odds and then converting that to probability. So you can do that. You had 10 minutes for the rest of the class, and then tomorrow there will be a AC on everything we've done so far. So there will, I think I will throw, there may be 1 or 2 questions on stating odds and converting between odds and probability, but there will be an AC tomorrow.